morning. My name is James Lee, and for my research project, I decided to examine the correlation between light pollution and people's perception of outer space. The invention of the light bulb is undoubtedly one of the greatest human achievements, so much so that it has been commonly compared to the invention of human-made fire. Artificial lighting has allowed human civilization to advance rapidly, even more prominently in the modern world. This shift to artificial lighting has approximately 80% of the world population and over 99% of the US and European population live in light polluted areas. To have a basic rundown, what is light pollution, or more specifically, sky glow? Sky glow is the artificial light scattered through the atmosphere, raises night sky luminance, meaning the sky have a screen of light that blocks from being able to see the night sky clearly. A good example of people's unawareness of light pollution was in Los Angeles, 1994, when an earthquake hit the city, causing a citywide blackout. Residents called various emergency centers, reporting a strange silvery cloud overhead. Unknowingly, that looming cloud is the band of the Milky Way galaxy. Though this was back in 1994, and the general population have been more educated since then, this still shows that many people are less aware of light pollution's presence. Light pollution's effects on human health is even less well known, even though it does cause significant change in the body. Human being diurnal animals, meaning they are active during the day and rest at night, extend their activities into dark hours. The normalization of night shifts cause disruption of expected circadian rhythm timing, evokes a multitude of downstream effects. Exposure to light at night suppresses the production of pineal hormones, melatonin. Lower levels in blood may encourage the growth of some type of cancers. Specifically, researchers now estimate that up to 30% of breast cancer may be due to the change in the circadian rhythm. Aside from human health impacts on light pollution, sky glow significantly affects the advancement of astronomical fields, so much so that an international dark sky reserve were made to preserve the dark sky for astronomical activities. The astronomy field is vital to human development and progression. Recent discoveries like the visualization of the Messier 87 galaxy's black hole illustrate the advancement's importance. Discoveries are also crucial in protecting Earth from threats of asteroids, since most of them are unknown. Most asteroids are currently unidentified, and discoveries of them can help to plan course of actions. Not only the field is crucial for discoveries, science observation of the Earth from outer space is increasingly important to understand how to maintain the planet's health. Observations of the most significant factors of Earth's degradation, climate change, are done by satellites. It constitutes a significant source of information about its effects by monitoring weather patterns, even able to find fertile and arable land for use. Now that we know having an interest in space is important, the younger generation should have an interest in the field, so then eventually more people will work in astronomy. A study done by CAIR created a model survey made to calculate interest in different parts of STEM fields. CAIR states that at the middle school level, a time when students are developing their own interest and recognizing their academic strengths are essential to gaining interest in the STEM field. The study was made to create an interest survey from students using the Likert scale with 5 variables: disagree, neither agree nor disagree, agree or strongly agree, and rate them on these prompts. These prompts can also be used in other parts of STEM. This model that CAIR created is what I will base some parts of my survey on. The second foundational source I examined most closely relates to what I am researching. The study by Kelly examined the correlations and differences between night sky watching interest and behavior to choosing astronomy as a vocational interest. This study was done on around 100 university students of different majors. The study uses a 7-point Likert scale, measuring the extent to which if they personally found astronomy to be an interesting or appealing vocation. The result concluded that night sky watching interest positively correlates in choosing astronomy and vocational interest. Previous studies that test interest in space were mostly done on adults or college students. To address the gap of my research, to address that gap, my research will be done on adolescents, specifically middle schoolers, meaning that are from the 6th to 8th grade. As supported by Kairos research, middle schoolers are chosen as the participant because it is the stage where they develop their own interests and recognize their own academic strengths. If more students could possibly lose interest about space because of light pollution, this will result in a lower amount of people who will work in the astronomy field. With less people in the field, civilization advancements will slow down its growth. The location of the participants is also important since the Kansas City metropolitan area is unique since it is a large urban area with surrounding rural areas relatively close by. So with that in mind, my research question is, does the light pollution level of an area affect the residents, specifically middle school students' interest in space? The participants are middle school students, meaning they are underage and need parental consent to be able to do the survey. I have to go through a two-step process to have permission to survey them. First, I email out consent forms to parents. The parents or guardians will then be able to sign a consent form if they allow their child to participate. After, I then email them back the link of the main survey, which the parent will also give to their student, and the student will have the option to opt out. The survey was distributed by SurveyMonkey Advantage, a third party that safeguards all data collected and is deleted after 5 years. The survey is set up using mixed method, meaning there are both qualitative and quantitative data. The first questions ask the participant to identify themselves by picking two options, rural or urban. I then ask the participant to pick a career in the Missouri Career Pathways and have them pick what they are currently interested in. This is done to see the difference between urban and rural, whether one chooses more STEM fields than the other. Next questions ask the participant to rate how their sky comparing to the more Bortle scale. The Bortle scale uses a 9-level numeric scale that measures the night sky brightness of a particular location, with 1 being clearly visible stars and 9 being barely visible stars. This was done to see how light pollution are perceived in different areas. The next part had the participant answer a 4.4 Likert scale on how often they perform a specific activity, and rated on a scale of never, not often, often, and always. The next portion of the survey also is the same, but this time asks the participant to rate how likely it is for them to perform a certain activity. The scale is rated as never, not likely, likely, and very likely. The reason why a forced Likert scale was used is because it reduces the reliability of human gravitating towards the neutral option when eliminating results in more diverse response. The last section of the survey asks the participant to fill out an open-ended text box. At the time of the survey was open, the Mars rover Perseverance landing was relevant. The participants were asked to answer what they know about the program, the point in which to see the difference between rural and urban responses. The next text box do is the same purpose and ask the participant what they think about space in general. The text box was created with the thought that if the responses are more in-depth, the higher the interest is. Of all students sent out, only 20 respondents that answered a survey, there are only 20 respondents that answered the survey, with 17 being reported they are from urban areas and 3 being in rural areas. This graph depicts the result of the participant when choosing the career cluster that they are interested in based on the Missouri Pathways. As one can see from the table above, the highest field was chosen was the STEM field, with 30% of the students responded that they are interested. Out of that, 1 out of 3, or 30% of rural participants said they were interested in the field, while 5 of 17, or 29% urban participants responded that they are interested in the STEM field. The result returns insignificant since the difference between the rural and urban participants in choosing STEM as a current interest are minuscule. When asked to compare the night sky to to the Bortle scale, 75% reported that their night sky falls to the 6 to 9 range, meaning that most of the participants perceive that they are under moderate to heavy effects of light pollution, though all 3 rural participants also reported to be in this range. Surprisingly, 25% of students who reported that they can see the sky more clearly are all urban participants. Noticeably, 10% who reported a 1 on the Bortle scale, meaning they perceive 0 effects of light pollution, even though they're also reporting they live in an urban area. This result means that the Bortle scale is not useful in self-identification of what one perceives different levels of light pollution. When asked to pick which one of the 4-point Likert scale from what questions best apply to them, significant results to point out are 65% of participants, they do not hear about space-related subjects in real life. This could possibly mean schools don't push space astronomy as much in their teachings. On the other hand, 55 reported that they do hear about space-related subjects in media, though no conclusion can be seen from that since 5% difference isn't significant. A large 85% of respondents report unfavorably to go stargazing, with all 15% of respondents that reported positively are urban. Even more notifiable, 95% reported that they are not interested in working in astronomy, with the only one respondent, 5%, likely to do astronomy is in the urban area. When asked about what the participants know about the Mars rover landing, 30% participants are knowledgeable about the topic. Out of that 30, only 1 of the participants were rural. 35% of participants share fewer knowledge or wrong understandings of the Perseverance landing, with most of those responses being, it was cool, or not much I know about the subject. 25% of the respondents shares no knowledge of the Mars rover landing at all. Noticeably, 10% of the participants mentioned Mark Rober, who is an engineer that previously worked at NASA and had made YouTube videos talking about the topics. This data is significant because the 2 participants that mentioned Mark Rober shows knowledge about the landing are urban participants. This means that even if light pollution negatively affects interest in space, media is still a form to spread awareness of the astronomy field. When asked about the participant general thoughts about space, 70% responded favorably. Out of that 70%, 20% wanting to learn more, most generally describe space as cool or interesting, with 100% of rural participants finding it interesting. This could show that less light polluted area means higher interest in space, but again, this is likely due to chance. 30% respondents said that they are not interested in space at all. What are the reasons why the results are so inconclusive? The population size of the study is very small, with only 20 participants doing the survey. The reason why this might be is because of the 2-step process, because of the participants are minors, which makes it harder to get respondents. Not only because of the small sample size, the population is extremely skewed to the urban side, with 17 people and only 3 in rural, which make most of the data insignificant. Now, as a brief conclusion and summary, my ultimate goal is to see if light pollution affects middle school students' interest in space. And as we saw from my insignificant findings, I can conclude that there are no concrete correlations to be made whether living in a rural area, meaning less light pollution, correlate positively with a person's interest in space. Of course, future research is necessary to determine the reliability of my results, with how far it can work with a larger population, and further refined methods could be revised. Thank you for listening. I am free for questions.
How did the choices you made when designing or implementing your research method impact your research process?
While designing my methods, because using the Bortle scale, it turned out quite unresolvable because participants' self-evaluation of the night sky is inaccurate to what they reported on the area they live in.
How did the limitations of your method or data influence your new understanding?
The small sample size causes by my results to be insignificant since there's an uneven ratio urban versus rural participants with 17%, with 17 urban and 3 rural. With skewed data like that, it is hard to compare and contrast to get significant data for my results.
Think back to the initial curiosity that sparked your inquiry. What other curiosities do you have, and how has this process prepared you to explore them?
I was initially interested in the subject because I've been living under urban cities for most of my life, but I still have a large fascination in space. And it bothers me that I cannot see the clear night sky. After my new findings, I am now also interested how media affects space, interest in space. Since I live in an urban area and still largely interested in space. This process has helped me because its method would relatively be the same since it's both an interest